So let's take a look at some other options we have when we're playing with physics inside Unity. Now, I have this scenario set up where the ball is dropping and we have a little bit of control over the ball. And that ball is running through these little bumpers here. Now, I'm going to do a real quick organization of my bumpers. If I look at my hierarchy and I select these bumpers, you can see that there is kind of an order to them, but there's the sunlight is interfering with the group of the bumpers, and I kind of want the first bumper to be at the top of the hierarchical list. Well, I can reorder this. I can simply click and drag that bumper up. Now, I need to be careful not to drop it on top of the floor, the main camera, or some of the other objects inside my scene, because that will nest it as a child of that object. But if I raise it just between two objects, you'll see a little rule pops up, or a line. That means that I'll place it between two objects. So I'm just going to move that up above the uppermost bumper. The second bumper is the bottom bumper in this list. So I'll grab this little stray down here and just move that up between the two bumpers. And so now I have three bumpers that are listed in a row, and I know from top down they follow the order of height here. So I have the top bumper, the middle bumper, and the bottom bumper. If I grab the top one and I look over in the inspector, I have in the box collider component, the box collider is the thing that governs collisions by other physics objects. So in this case, I'm dropping the ball. It's running into this box collider, and you can see that I have a couple of parameters here, and the one that I want to pay special attention to is the material. Because in the case of colliders, I can apply a physics material to that collider to give it different kinds of effects. So if I want it to be bouncy or slippery or have some friction, I can apply a physics material. Now, the place where I get physics material, the default physics material I loaded as an asset when I created this project. And if you remember way back when we started, we created a new project, I checked a couple of different packages, and one of those packages was the physics material. So if I look inside my assets, inside my standard assets, you can see that I have physics materials. Now, if you miss that and you don't have a standard assets folder with physics material, you can simply go to Assets, Import Package, and choose to import physics material. Once the import is complete, you'll have inside your assets folder a standard assets folder with the physics material. Now, if I double click inside my physics material, I get a couple of different materials to start with. I have a bouncy material, icy, metal, rubber, and wood. Now, if I go back to my first bumper, and let's say I click and drag this bouncy material, and I drop that on top of the box collider material, that collider will inherit a bouncy effect. So I'll just hit the play button and test that out. And you can see now when that ball drops and hits that first bumper, it bounces off. So I'll run that one more time, and I can see that that first bumper is bouncy. I could do the same thing with the sphere rather than making each individual bumper bouncy, or maybe the ball itself also has some kind of a bounce to it. I could just select the sphere and load in the sphere collider in its material channel. I could load in another material. Now there is an alternate way to do this, and I'll do this with the second bumper. I'll select the second bumper down in my hierarchy, and in the material field, as long as I have the physics material loaded as a package, I can just click on this little bullet to the right. So I'll identify the box collider material, and I'll just click on this little bullet to the right, and that opens up a window that allows me to choose all the available physics materials. Now, if I load a material like bouncy, and I hit the play button, now I take one bounce, two bounce, so I have a very different setup now. My sphere is kind of bouncing around on the bumper, and then it hits that third bumper, and of course the third bumper is not yet bouncy. I'll save my sphere from rolling off the edge off into oblivion here. In the event that I want to remove that physics material, the way that I would do this is I would go identify the material channel, I would click on the bullet, and from this list I would choose none. So now that second bumper is no longer bouncy. I'll give that a quick test, and it is in fact, well, it looked like it was still bouncing. So let me take a closer look and see what... Looks like I did not remove it. Maybe I hit the wrong button, so let's try that again. Double click on none. There we go. I've removed that. So now it is no longer bouncy. So I can apply physics materials to any object that has a collider. Now remember, these objects at this point have not been had a rigid body physics added to them. So these are just standard shapes. They happen to have box colliders, and of course, at that point, we can add physics materials to them. So anything that's falling through space or moving through space will start to react to that in a different way. Now, in addition to that, we can start to apply different kinds of physics components to these objects. As an example, I'm going to create a cube, and this cube, I'll just drop this somewhere where I think I could interfere with the sphere for just a moment. So I think that's lining up just right. I'll take a quick top-down look. It looks okay. I'll make this a little bit bigger. I'm going to extend it along the X. I'm going to reduce it along the Y. I'll move this up a little bit. I'm going to make it wider along the Z, so I have this nice big platform here. And again, this is just a real quick experiment. So I have this plane here. I'm going to move it over just a bit. So I'm just kind of eyeballing this. I'm not paying too much attention to what the transform component position is. But I can clearly see that my sphere is going to land on this plane when I hit play. And I can just test that really quickly. And it does exactly what I figure it's going to do. Now, with that new cube selected, what I'm going to do is I'm going to go to Components, Physics, and I'll add a hinge joint to it. So I'll introduce a hinge, and when I do that, there's a little orange marker that pops up here. It's right in the center. It's very small, kind of hard to see, but what that means is that we've just added a hinge, and this axis is the rotation point from which the hinge is going to rotate. Now, this is the wrong position, because this will rotate the foreground and background. In fact, if I hit the play button, we'll start to see that hinge starts to tip and it dumps the ball, and it'll kind of wobble back and forth. So let me toggle the play button off. So again, that little orange indicator, we can think of that as kind of the axis or the skewer with which it's going to rotate around. I want to change that. And I can do that by selecting the cube, and I'll look at its components. And if I look in the hinge joint component, I can see that under the axis, currently the x-axis is set to 1. So we have values in the axis of x is 1, y is 0, and z is 0. The 1 represents the active axis with which this, this hinge is rotating. So if I zero out the x, and I go to my y-axis and I type in 1, you'll see that we just flipped. It's kind of hard to see in the screencast, I bet. Oop, I didn't want y. It's actually, the hinge is pointing up right now, which would mean that this whole platform would spin, which is not what I want. So let me find my axis. Let me zero out the y. I meant to add 1 to the z. There we go. And so now I can see that that hinge is running in line with my blue or my z-axis. And so what I'll get here is kind of a teeter-totter effect with this panel. So when I hit the play button, now I can see, and I can actually just kind of try to balance on this thing, and then eventually it dumps me off into my bumpers. Okay, so just something else that I can play with to add a little gameplay feature. Now, in addition to adding the hinge joint, if I look down here towards the bottom or in the middle, it says use spring, and if I check the use spring and I bump up the spring value, and I'll just bump it up to something from like 0 to 10, and I'll hit the play button. What we've done is we've just kind of stiffened that hinge to where it'll spring back into place. You can see it starts to wobble, and it's trying to reach its original position. Okay, if I tighten up that spring value even more, say to 20, that spring tries even harder to keep that platform in place. So it's not as wobbly as it was, and in fact when we walk off the edge of it, it springs back pretty quickly, and it'll slowly kind of wobble back. And if we want it to not wobble so much as it's resetting itself, we can play with the damper. Okay, so now we have some basic elements that we can start to play with. We have a script that's controlling the input of our sphere. We have some physics materials that we can apply to anything with a collider. And in addition to that, we can start to play with hinges and other effects that we can find under component physics joints. Okay, so experiment with some of those elements. In the next presentation, I'll make a real quick pass and talk about the scripts again. We'll take a final pass on the aesthetics of this. And then I'll talk about the build process to where you can actually build the application that you'll submit as your assignment. We'll do that in the following presentation. And then once we wrap up the presentation, take the knowledge that you have, the knowledge that you're building, and experiment and make a simple playable gravity game inside Unity using what we've just learned here today. But we'll catch up in the next presentation to make one final pass at this project and learn how to package it for submission. But we'll do that in the next presentation.